So still we have two topics, that is HBASE and Hive is there. First we'll just discuss about HBASE and then we'll move on to the Hive. Okay, there is a combination of HBASE and Hive is there. That is also mostly used in most of the places. Okay, so let's talk about HBASE here. So as you can see in the slide, HBASE is an open source, distributed, column-oriented database built on top of HDFS based on Bigtable. So there are different terms, keywords are used in this slide. It is open source. You are very much know what is open source. It is actually freely available. Even the source code is also freely available. HBASE is the Apache HBASE. Okay, it's an open source product, and you can use the HBASE in the distributed environment. Okay, so that is the main important aspect you can note here. And then it is column oriented. So the HBASE is using the data model mostly used in the HBASE is column oriented or column style. The column style is actually based on the big table concept. Okay, so that's also there. Database built on top of HDFS. Again, it is using HDFS. Okay, it is using HDFS concept, that is HDFS Hadoop distributed file system, and based on Bigtable. So these are the concepts involved in HBASE. Now, so what is HBASE is? As we said, it is a distributed data store that can scale horizontally to thousands of commodity servers and petabytes of indexed storage, right? That means the two things you can understand here. It is supporting horizontal scalability up to maximum any number of level. At the same time, it can handle maximum any number of data size. Okay, so even it handles petabyte of indexed storage, right? So this is the key points you can see here, right? Yeah, distributed data store that can scale horizontally. See, we already talked about the scaling. Maybe you can do the scaling in vertical wise or in the horizontal wise. This HBASE is supporting scaling horizontal with thousands of commodity servers, and even it supports the maximum limit of data size. And the next point is designed to operate on top of the Hadoop file system, Hadoop distributed file system, HDFS. The backbone or the fundamental idea of the functionality of HBASE is HDFS. Okay, it uses HDFS concept to work on, or otherwise Cosmos file system, KFS, also called as cloud store. Okay, even the HBASE is also supporting cloud store, and for scalability, fault tolerance, and highly available. So these are the three, three properties you can see here. It is very much scalable, and then fault tolerance is also there because it is providing horizontal scaling. Fault tolerance is there, and then it is highly available. That is, data is very much or highly available here. And what are the major benefits we can get out of HBASE? So as it supports the distributed environment or distributed storage, that is one of the key advantage we can get. And then table-like in data structure. So it is not exactly using a table format where how you use in database management system, but it is actually using a table-like data structure that is column-based, and it supports again multi-dimensional mapping. When you are saving the data, it is supporting multiple dimensional values or multiple dimension data, where you can do the mapping also. And other benefits are highly scalable, highly available, and it can produce a high performance. And the backdrop or the how it is evolved, it is started toward by Chad, Walters, and Jim in the year 2006. And then Google releases paper on Bigtable. And based on the Bigtable, again, they started working on this particular project. The 2007 initial HBASE prototype created as Hadoop Contrib. Like Hadoop Contrib, there is a prototype. So based on that Hadoop Contrib prototype, the initial HBASE prototype also created. And the year 2007, in the month of 10, then first usable HBASE was released. Okay. Then next to that, 2018, the first month, Hadoop became Apache top level project and HBASE becomes sub project. So Apache was developing a lot of project. Apache, that is Hadoop, then HDFS, then Apache. Now you can see Spark, Scala. So a lot of projects are going on in Apache. So here in the Apache, the HBASE becomes a sub-product project in the year 2008. And year again 2008, in the 10th month, the first a complete version of the HBASE was released. Just about 1 year gap, the Hadoop, the major usable version was released. Okay, this is a small history about how the Hadoop, how the HBASE was developed. And so there are other still some more points on HBASE. The HBASE, the tables do not have one primary index, the row key. So it is not like how we are using a primary key in the normal relational tables. So the HBASE is not using the exact one primary index in the tables. Okay, so then there is no join operators are used in the HBASE, and it scans and queries can select a subset of available columns perhaps by using a wildcard. That is how you can use the query and how you can access the data based on using some wildcard as well as some of the column values. Okay, so what are the column value and what are the wildcard characters you are using? Based on that, you can access or you can use the queries. So there are three types of lookup. So lookup in the sense how you can find a particular data or particular information from the HBASE. So fast lookup using row key and optional timestamp. So maybe you can use the timestamp along with the row key to look up or to find a particular data or particular information from the HBASE. And then full table scan, that is also another possibility, but it will be very time consuming to find a particular data or particular information from the HBASE. And range scan from region start to end. So maybe you can fix up a range in the HBASE from this point to the ending point. You can search. Okay, you can just look up the required content, right? So instead of checking the entire database or entire HBASE, you can fix a range. If you know the range, you can fix the range, and then within the range you can start finding out. Okay, so these are the different types of lookups or the way you can search the content or the information in the HBASE environment. And next to that, what is HBASE is? HBASE is limited atomicity and transaction support. So we already spoke about the ACID properties are used up to certain level only in the distributed computing. So it is actually HBASE is supporting a little bit with limited atomicity property and transaction support, and supports multiple batched mutations of single rows only. So maybe you can use a batch type of processing or batch type of queries, which can use in the single rows. Okay, and then data is unstructured and untyped. So mostly the HBASE, whatever the data you are storing will be unstructured and untyped. So that we already discussed in the distributed or in the especially in the NoSQL databases, mostly the data will be in the unstructured form, and then where there is no clear type. Okay, data type is not very clearly mentioned here, so you can use any data type. Okay, so and then the next one is no accessed or manipulated via SQL. So generally to access the HBASE, mostly we won't use the SQL commands or the SQL statement. Instead, what you can do, you can use some programmatic access from the program, okay, from the host language program. Maybe you can use some Java coding or REST or Thrift APIs. Okay, so Apache Thrift is actually a interface definition language. Okay, so it uses the API to interact with the other databases as well as the other languages. It uses the API for interaction. It is actually interface. And then scripting via JRuby. So you can do scripting. JRuby is one of the scripting language used in the this particular environment, and you can use some scripting language JRuby. Through this, you can communicate with the HBASE. So why big table, right? So we already said about what is a big table. Maybe a table in the very bigger size. Okay, because we are dealing with a very huge volume of data, very high volume of data. So there we need big table concept to store the entire amount of data in the table format. Okay, it is not strictly the how we create the table in the relational database management, but it will look like a table. Okay, so the performance of the RDBMS system is good for transaction processing, but for very large scale analytic processing, the solutions are commercial, expensive, and specialized. And very large scale analytic processing, because we are dealing with a very high volume of data, right? In that case, definitely we'll go for very large scale analytic processing. Okay, the amount of data is taken for processing is huge. Okay, so that's why it's large scale, and even we are taking the data from the multiple sources or the distributed places. And maybe you can use some big queries and big databases. And why HBASE? HBASE is a big table clone. Even it is using a column-based data model. That is actually the basic idea is big table. Okay, it is open source and it has good community and promise for the future. So maybe even in the future also, even if your data structure is more changing, or if your type of data is changing, and then maybe if you're dealing with even more still higher volume of data or higher velocity of data, so in those future related situation also the HBASE will be more supportive, and it is developed on top of and has good integration for the Hadoop platform. So HBASE is one of the sub project of Hadoop. We already spoke about this. This Hadoop will be, this HBASE will be supporting very much the Hadoop platform. Suppose if your project is running already in Hadoop, then you can very much use the HBASE. Okay, so it will be supporting without any difficulties there. And it has a cascading connector. So this is another concept used in the HBASE. Maybe whatever the connections you are making or providing with the distributed databases, there will be a cascading. That means you'll be connecting to different sources in the sequential manner. And HBASE benefits in RDBMS. So here HBASEs are not using real indexes. There is no real index values used. Okay, so like how we use in the RDBMS. Relational database management system will be using real index values and automatic partitioning. So since the HBASE is used in the distributed environment, the partitioning of your table and then the entire data can be done automatically, right? And then scale linearly and automatically with new nodes. So the automatic partitioning is not possible in the RDBMS. And here scale linearly and automatically with new nodes. So whenever you are going to add a new node, that is whenever you are going to increase the scale, then it is obviously it is supporting everything. And then commodity hardware can also be included here in the HBASE, and new hardware, and then new the entire architecture, everything can be used in the HBASE. And fault tolerance, so it is highly fault tolerance in nature, and it supports batch processing. Okay, but in the real-time databases, we talked about real-time data processing, but here in addition to that, the HBASE will be supporting batch processing also. And this is what the data model has been used in the HBASE. As we said, it is a column based, as well as it uses a column families, and then this particular data model is from the big table concept. Okay, so it is actually using a big table concept, and tables are sorted by row. It is how we are doing in the RDBMS. Like you can sort the table here, and then table schema only define its column families. Okay, so only you can define only the column families, not in the row wise. Okay, so each column consists of any number of versions. So maybe each and every column you can have any number of versions. So you can see in this example, in the column family content, and then another column you have the other values, and then the next column you have the other values. Okay, so the entire 3 columns comes under one column family, right? So you can have different number of versions there, and then columns only exist when inserted, nulls or free. So only when you add data there in the column, then only it is going to be, you are going to just insert. So otherwise, if any data is missing there, it is, or nulls are free. That means no need for any compulsive data there. And then columns within a family are sorted and sorted together. So whatever the data or whatever the information you are saving under your particular family will be sorted in one particular order. Okay, so maybe the other point is row, family, column, timestamp that leads to the value. So what are the values that you have in the row key, and then column, family, timestamp, and then finally will be so with this attribute you are going to refer the value. So to refer the value, you will be having row, what is a row name, what is a family, and what is a column used, and what is a timestamp. So we already spoke about timestamp is an optional one. Okay. And who are the members of this HBASE architecture? So we have the master and region servers. Okay. So before we talk about this, we'll just we'll see the diagram and we'll come back here. And here the architecture, this is actually a HBASE architecture. And you can see here HBASE, you have a set of architecture, set of components here. And then you have the Hadoop also. Okay. The HBASE is working on Hadoop. And again, it uses HDFS file system that we already discussed. Okay. And here you can see the Hadoop is divided into having node, data node, different set of data nodes are there. And when it comes to the HBASE, it is actually using HDFS client between your Hadoop and then HBASE as an interface. Okay, there is a HDFS client is there in between. And you have the HBASE here. This actually, the HBASE, you can divide into H region server, H region, based on the region. Okay, so region is actually a kind of location, or maybe you can refer the region as your location, right? So in a particular location, the HBASE will be monitored by the master, that is the H region is there. So this will be monitored. So how many number of regions are there, region servers are there. So everything will be monitored by the H master. You have the H master here. Okay. And you have the region server slaves. So here the region servers are actually slaves, and this will be the H master will be the master. Okay. He is actually coordinating all the H region server. So here in the H region, you can see how the data is stored in the form of storing file that we say is a HBASE file or HDFS file system. Okay, so we already said HBASE is supporting HDFS file system. So whatever the data you are storing in the column format or in the table format will be in the HDFS file. So it will be supporting HDFS. Okay, so then only you can able to process the file with the help of Hadoop. Okay, so if you are saving this information on the data other than the HDFS, it will be difficult for the Hadoop system to process. So here you have the memstore. So memstore where the file, whatever the data or information you are storing, that will be processed with the memstore. Okay. So here HLog. So whatever the transaction, whatever the the interactions happening between the H master and to the Hadoop system. So all the transaction, all the interaction with the other component or the other elements will be stored in the HLog. Okay, it's a log file. So in this way, you have two things. One is the region server, another one is the H master. And again, the client will be interacting with the H region server, sometimes directly or with the help of the Zookeeper. Okay, so Zookeeper we already studied is one of the element or one of the component available, one of the tool available in the HDFS environment. Okay, so that we are going to discuss now. You have the H master and then Zookeeper, and the H master will be interacting with the Zookeeper, and again there will be a coordination between the client and then H master through the Zookeeper, and this H master will be controlling all the H region server. Okay, so this is how the HBASE system is being used in the real time. Okay, so in the big data environment. So now let's talk about this point. So master, you have the H master responsible for monitoring region servers, we already said, and then load balancing for regions. So how much load should be load in the sense the number of requests that is obtained from the client. Okay, so suppose if the lakhs and lakhs client are interacting, more number of requests are coming, and then based on that request, that should be balanced among all the region servers. That is actually the role of master, right? And then redirect client to correct region servers. So what are the region servers are there? So it is actually redirecting or connecting the client to connect with the proper region servers. And then the current SPOF. SPOF here is single point of failure. Okay. So here, if any failure is happening, this failures will be notified by the master. If any H region server is got failed, then those failures will be intimated by the M master, that is Hadoop master, sorry, HBASE master. And then the region server slaves, the main task performed by the region server slaves are serving request. So whatever the request is made from the client or by the client, then those requests will be processed by the region server, and then send heartbeat to the master. That means what? Whatever happening in the region server, so everything will be updated to the master. Okay. So the control as well as the status updation will be sent to the master. And throughput and region numbers are scalable by region servers. So the throughput, that is maximum number of the process that you can complete, and then the scalable, how many number of clusters or how many number of processing unit you can extend, so that you can decide on. Okay. So these are the points, just we have to discuss about the HBASE, and we'll just discuss Zookeeper also. Zookeeper is a cluster. It's actually it is controlling all, interacting with all master and region servers of your HBASE. Okay. Again, the region servers will be using your HDFS file system, right? And then here HBASE depends on Zookeeper, and by default it manages a Zookeeper instance as the authority on cluster state. So Zookeeper, generally in the Hadoop environment, Zookeeper is a coordinator. Okay, so he'll be coordinating with all the other remaining frameworks, that is elements or the component in the framework. Okay, similarly here also the HBASE will be coordinated by the Zookeeper to interact with your master and then region servers.
Hey there. Subscribe to my channel and also press this bell icon.